My name's Wendy Shaw, and I'm a biophysical chemist. We're trying to understand how nature makes enzymes so we can make artificial enzymes that function just as well, but are much more stable and able to operate under conditions that are relevant for human applications. The challenge with enzymes is that they're extremely complex, and we've been studying them for years and years and years, and because of their complexity, we don't fully understand them. They're very specific for one particular reaction, and they function in a very narrow chemical space. And so what we're looking for human applications are minimalistic catalysts that have all the features that they need from the enzyme and are, in that case, able to operate as efficiently, but they're easier to make, they're much more stable, they're easier to keep in conditions that would be relevant for human applications. Right now, there are a number of problems with catalysts. In some cases, they aren't specific enough, so they don't react specifically with the molecule that you want them to react with. Sometimes they're not fast enough, sometimes they're not stable enough. All of those challenges are things that need to be overcome so that we can, in our case, we're very interested in realizing renewable energy applications and being able to have that widespread use of solar and wind energy. So right now, if the sun isn't shining or the wind's not blowing and you only had renewable energy, you wouldn't have any energy options. By having a catalyst that can interconvert those energies into some sort of storage and bring it back to electricity when you need it, you would be able to enable solar or wind energy as frequently as you like. So CO2, for instance, CO2 can be converted to methanol, would be the first substrate that you'd convert to. So you could think of storing your electrons effectively within methanol and then getting them back out later. If you wanted to take energy from a solar panel or a windmill, for instance, and store that, let's say you had CO2, you could take CO2 and you could take those electrons and ultimately convert that with a couple of reactions into methanol. If you could do that interconversion without a lot of energy loss, then that would allow you to store those electrons in the methanol until you were ready to use them. And that could help to balance out the oscillations in the availability of renewable energy power.